Hello, this is the video number 5 of the Cisco CCNA course, Chapter 5, Ethernet. In this chapter we will talk about the Ethernet protocol. Specifically, we will describe the operation of Ethernet sublayers. Also identify the major fields of the Ethernet frame. We will describe the purpose and characteristics of the Ethernet MAC address. In the Address Resolution Protocol, we will describe the purpose of the ARP, explain how ARP requests impact network and host performance. Also, we will explain basic switching concepts and compare fixed configuration and modular switches. Ethernet is the most widely used LAN technology. It operates in the data link layer and the physical layer. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. It supports data bandwidths from 10 MB per second to 100 GB per second. Ethernet standards define Layer 2 protocols and Layer 1 technologies. It relies on the two separate sublayers of the data link layer to operate. First, Logical Link Control (LLC) and the MAC sublayers. In graphical context, these are our OSI7 layers, and the Ethernet network belongs to the data link and the physical layer. The Logical Link Control (LLC) is a handles communication between upper and lower layers. It takes the network protocol data and adds control information to help deliver the packet to destination. It is implemented in software, and its implementation is independent of the hardware. The MAC constitutes the lower sublayer of the data link layer. It is implemented by hardware, typically in the computer NIC. It has two primary responsibilities. First, data encapsulation. Second, media access control. Data encapsulation includes frame assembly for transmission and frame disassembly upon reception of a frame. Additionally, the MAC layer adds a header and trailer to the network layer PDU, Protocol Data Unit. This operation provides three primary functions. First, frame delimiting. It identifies a group of bits that make up a frame. Also provides synchronization between the transmitting and receiving nodes. Second, addressing. Each Ethernet header added in the frame contains the physical address that enables a frame to be delivered to a destination node. Third, error detection. Each Ethernet frame contains a trailer with a cyclic redundancy check, CRC, of the frame content. Media access control. It is responsible for the placement and the removal of frames on the media. This layer also communicates directly with the physical layer. If multiple devices on a single medium attempt to forward data simultaneously, the data will collide, resulting in corrupted or unusable data. Ethernet provides a method for controlling how the nodes share access through the use of a Carrier Sense Multiple Access (CSMA) technology. Carrier Sense Multiple Access (CSMA) process. It is used to first detect if the media is carrying a signal. Then, if no carrier signal is detected, the device transmits its data. If two devices transmit at the same time, it's called a data collision. There are two commonly used methods. CSMA, collision detection. The device monitors the media for the presence of a data signal. If a data signal is absent, indicating that the media is free, the device transmits the data. If signals are detected, showing that another device was transmitting at the same time, all devices stop sending and try again later. While Ethernet networks are designed with a CSMA CD technology, with today's intermediate devices collision do not occur. Wireless connections in a LAN environment still have to take collisions into account. Another method is the CSMA collision avoidance. The device examines the media for the presence of a data signal. If the media is free, the device sends a notification across the media of its intent to use it. Then it sends the data. This is used by 802.11 wireless networking technologies. MAC address, Ethernet identity. The MAC address was created to identify the actual source and destination nodes within an Ethernet network. This is a 48-bit binary value. expressed as 12 hexadecimal digits. It is the result of IEEE enforced rules for vendors to ensure globally unique addresses for each Ethernet device. There are two principal rules for the vendors. First, they must use the vendor's assigned OUI, organizationally unique identifier, as the first 3 bytes. Second, all MAC addresses with the same OUI must be assigned a unique value in the last 3 bytes. Frame processing. The MAC address is a born-in address, PIA, because it is born into RAM on the NIC. This means that it cannot be changed by software. MAC addresses are assigned to any device that must originate and/or receive data on the network. When a device is forwarding a message to an Ethernet network, it attaches a header information to the packet. It contains the source and destination MAC address. Each NIC views information to see if the destination MAC address in the frame matches the device's physical MAC address stored in RAM. If there is no match, the device discards the frame. If it matches, the NIC passes the frame up the oscillators, where the decapsulation process takes place. Ethernet encapsulation. Early versions of Ethernet were relatively slow at 10 megabits per second. Now they operate at 10 gigabits per second or even faster. Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. Ethernet frame size. Ethernet 2 and IEEE 802.3 standards define the minimum frame size as 64 bytes and the maximum as 1518 bytes. A frame with less than 64 bytes in length is considered a collision fragment or wrong frame. If the size of a transmitter frame is less than the minimum or greater than the maximum, the receiving device drops the frame. At the physical layer, different versions of Ethernet vary in the method for detecting and placing data on the media. Ethernet frame. The primary fields in the Ethernet frames are preamble and start frame delimiter fields. This is used for synchronization between the sending and receiving devices. Length type field defines the exact length of the frame data field, also describes which protocol is implemented. Data and path field contains the encapsulated data from a higher layer, an IPv4 packet. Frame check sequence field used to detect errors in a frame with cyclic redundancy check, 4 bytes. If calculation match at source and receiver means that no error occurred. MAC addresses and hexadecimal. MAC addresses use hexadecimal numbering. It provides a convenient way to represent binary values. It is a basic SIM system that uses numbers from 0 to 9 and the letters from A to F. The technical representation of hexadecimal is preceded by 0x. For example, the number 0x83 in hexadecimal base is equal to 10, 10 for the A and 0011 for the 3 in binary base representation, and it is equal to 163 in decimal representation. MAC address representation. The ipconfig-o command can be used to identify the MAC address. For example, here. Unicast MAC address. A unicast MAC address is the unique address used when a frame is sent from a single transmitting device to a single destination device. Broadcast MAC address. A broadcast packet contains a destination IP address that has all ones in the host portion. This numbering in the address means that all hosts on a local network broadcast domain will receive and process the packet. Multicast MAC address. A multicast address allows a source device to send a packet to a group of devices, but those devices that belong to a multicast group are assigned a multicast group IP address. MAC address. This address doesn't change. It is similar to the name of a person. It is known as a physical address because it is physically assigned to the host NIC. IP address. It is similar to the address of a person. It is based on where the host is actually located. It is assigned to each host by a network administrator based on its local network. Both the physical MAC and logical IP addresses are required for a computer to communicate. Just like both, the name and address of a person are required to send a letter. End-to-end connectivity. A source device will send a packet based on an IP address. One of the most common ways source device determines the IP address of a destination device is through a domain name service (DNS), in which an IP address is associated to a domain name. IP addressing determines the end-to-end behavior of an IP packet. IP packet is encapsulated in a frame specific to the particular data link technology associated with that link.
The purpose of ARP is to provide the MAC address to the sending node that corresponds to the IP address, so the information can be correctly sent. ARP provides two basic functions. First one, resolving IP addresses to MAC addresses. And second one, maintaining a table of mappings called ARP cache. ARP cache is used to find the data link layer address that is mapped to the destination IP address. This happens when a packet is sent to the data link layer and needs to be encapsulated into a frame. Layer 2 broadcasts to all devices on the Ethernet LAN to know which one has a known IP address. The node that matches the IP address in the broadcast will reply. When the sending node receives the MAC address of the destination, it adds the MAC address and IP address to the cache or map. After the sending node gets the corresponding MAC address, it forwards the information to the destination. In switching, we must know that a central device connects various end devices on most Ethernet networks. A Layer 2 LAN performs switching and filtering based on MAC addresses. The LAN builds a MAC table to make decisions. A switch is a device that uses the MAC address to direct network communications through a port to a destination node. It determines how to handle incoming data frames by using the MAC address table. The switch receives a broadcast frame from PC1 on port 1. The switch enters the source MAC address on the switch port that received the frame into the address table. Because the destination address is a broadcast, the switch floods the frame to all ports except the port on which it received the frame. The destination device replies to broadcast with a unicast frame address to PC1. The switch enters the source MAC address of PC2 and the port number of the switch port that received the frame into the address table. The switch can now forward frames between source and destination devices without flooding. The switch has some basic settings known as duplex settings. It has to be the communication is directional bidirectional. These settings are called half duplex and full duplex. Half duplex communication means that the sending and receiving data don't occur at the same time. On the other hand, full duplex means that sending and receiving data occur at the same time. It is also necessary to have the correct type of cable for each port. The connections among switches, hubs and routers require specific cables. Now most devices use the Auto MDX feature. There are two frame forwarding methods, store and forward and cut-through. In store and forward switching, when the switch receives the frame, it stores the data in buffers until the complete frame has been received. In cut-through, the switch acts upon the data as soon as it's received, even if the transmission is not complete. Forward switching has the lowest level of latency and is the most typically used. Fragment-free switching stores the first 64 bytes of the frame for forward. Switches use two memory buffer techniques, port-based and shared memory. Port-based frames are stored in queues that are linked to specific incoming and outgoing ports. Shared memory buffering deposits all frames into a common memory buffer, which all the ports on the switch share. Fixed configuration features or options cannot be added to the switch beyond those that originally came with the switch, while modular switches offer more flexibility in their configuration. The major types of Layer 3 interfaces are Switch Virtual Interface, the Router Port, and Layer 3 Ether Channel. To sum up, we know Ethernet is the most widely used LAN technology used today. We found that replacing hubs with switches is very useful. Also, we know the importance of ARP and ARP cache. Furthermore, we identified that Layer 2 switches can create a MAC address table to forward decisions. Finally, we know Layer 3 switches also perform Layer 3 routing functions. Thank you for your attention.